So hello everyone, welcome to this new video, new session, and here now in this session I'm going to discuss with the module 5. The name of the module 5 is IIR filter designing. Okay, and from module 5 we are going to discuss some of the important concepts because module 4 mostly all of the concepts I've tried to cover it. Okay, so from module 4 it's it from my side. I'm not going to do anything from module 4 now. Some of the concepts from module 4 has been done. Okay, some simple theory part is there that if time proceeds and time is there, I'm going to do it. So then whatever is there till now I've taught in the previous sessions, that comes under module 4, that is FIR structures and along with the Windows problems of frequency responses and filter designing. Okay, FIR filter designing is done. Now from module 5 I'm going to discuss the IIR filter design. Okay, IIR filter design problems mostly consists of the partial fractions. So those who are thorough with partial fractions, right, the method of partial fractions to finding the values of A and B, then doing it is very easy. You can easily score marks. This IIR filter design problems are very easy if you know partial fractions very well. Partial fractions are already done in your previous semesters or in the PUC as well. You have gone through the partial fractions. Again, I'm not going to teach that and sit here. Okay, so how much ever explanation is required for partial fractions in the less amount of time I'm going to give it. Okay, then I'm going to start with the module 5 one concept, that is IIR filter design. Under that we are having two methods. Okay, first method is IIM, that is impulse invariance method. The name of this is IIM. Okay, in the problem they would be mentioning you using IIM method you should be solving. After, if they mention like that for IIR filter design, whatever I'm solving here, like that only you should be solving in the exam as well. Okay, very easy. So this is the formula for IIM method. That is one equation they would be giving you like this in form of 1 divided by something, that is you can by guessing the system function equation only you can say that you should be using partial fraction and solving this. Okay, all the problems in here you should be using partial fractions and solving. Okay, the method of partial fractions. Here the simple concept is 1 divided by s minus p of k, p suffix k, pk, and this pk stands for pole, and it should be converted to the z plane, that is h of z in h of s. This is written, and after converting it to z plane, that is h of z, it would be changed to this form. That is, we should be bringing h of s to this form first. Okay, after that, and in place of pk you should be writing 1 divided by 1 minus e to the power whatever the value of root we have got here, that is pole or root, it's one and the same. That you should be substituting here into t, where this t stands for time period. That they would be mentioning it in the question. But in this question here, first problem, they have mentioned the frequency. So using frequency we can calculate time, right? Yeah, into z inverse. Okay, so this is the conversion here if you should be knowing for IIM method, that while solving you would be understanding. Okay, I'm going to tell you how to do it. So this was the complete introduction of this module. So we are going to solve two problems in this session, very interesting problems related to partial fractions. Without wasting much time, I'm going to solve it. So here they have given h of s is equal to 1 divided by s plus 1 into s plus 2, right? Now use the concept of partial fraction, that is 1 divided by s plus 1 into s plus 2, that is equal to, we can split it and write it as a divided by s plus 1 plus b divided by s plus 2, right? Now in order to cancel the denominator we should be cross multiplying and solving, that is a into s plus 2 plus b into s plus 1 divided by s plus 1 into s plus 2, so that the denominators would be getting cancelled and we would be left with 1 is equal to a into s plus 2 plus b into s plus 1, right? So this is one equation you have got. So this equation you name it as equation star or something. Okay, now using this you should be finding the value of a and b. To find the value of a, we should be making this b equal to 0, right, according to partial fraction. So how this b would be equal to 0? By substituting the value of s is equal to minus 1. If we make s equal to minus 1 plus 1 would be equal to 0. This whole b would be equal to 0. We would be left with only one a term so that we can solve for a. So the value of, first put the value of s as minus 1 in this equation here. So 1 is equal to A into, put the value as minus 1 plus 2 plus B into minus 1 plus 1, so that this whole term would go vanish. We would be left with A into minus 1 plus 2 is 1. So our value of A is equal to plus 1. Right? Similarly, put S is equal to minus 2 to cancel out A, so that you would be getting the value of B. That is, in this equation only, 1 is equal to A into minus 2 plus 2 plus B into minus 2 plus 1. So this would be 0. We would be left with B into minus 2 plus 1 is minus 1. So our value of B, we are getting it as minus 1. So A and B values we got. Now put it in equation star and solve. That is, now our equation star would be equal to 1 by S plus 1 into S plus 2, that is equal to, the value of A is plus 1 by S plus 1 and the value of B is minus 1, so minus, I am writing it here, by S plus 2. Okay. Now I have told you, right, it should be of this form, 1 divided by S minus Pk. But here we have 1 divided by S plus 1 plus 2. So what I am doing is I am taking minus sign outside, minus of minus 1, because minus of minus is plus 1 only. Here again the same thing, 1 divided by S minus of minus 2. So here you can see that the value of Pk, that is the roots, the value of roots are, one is minus 1 and minus 2 in S domain. Now in Z plane, according to the IIM method, in Z plane it is written as 1 divided by 1 minus e to the power, the root here, that is minus 1 into the time interval t. Right, the t time interval we have not found, but in the question they have given the sampling frequency as 5 radian per second. Okay, that is, they have given the value of frequency as 5. So how you know how t is related to frequency? F is equal to 1 by t. Right, so t would be equal to 1 by f. So that is 1 by 5. 1 by 5 is 0.2. So our value of capital T is equal to 0.2. So here in place of t we should be writing minus 0.2 Z inverse. Here again the same thing, 1 minus e to the power, the root is minus 2 into 0.2 Z inverse. So that is equal to 1 divided by 1 minus e to the power minus 0.2 Z inverse minus 1 divided by 1 minus e to the power 2 into 0.2, that is minus 0.4 Z inverse. This is for h of z. Now we can further solve this equation and simplify and write it, or you can conclude it here, no problem. So let's further simplify and let us see what answer we are getting. Let us cross multiply here. 1 minus e to the power minus 0.4 Z inverse minus of 1 minus e to the power minus 0.2 Z inverse whole divided by multiplication of these two, 1 minus e power minus 0.2 Z inverse into 1 minus e power minus 0.4 Z inverse. No simple mathematical calculation, solve it. That is 1 minus e power minus 0.4 Z inverse multiply minus, so minus 1 minus minus plus 0.2 Z inverse, minus 1 plus 1 would be getting cancelled. Okay, so I again multiply 1 and 1, so 1, and this term you write it first, then these two multiplied, that is minus e power minus 0.2 Z inverse, then we have minus minus plus e power minus 0.2 and minus 0.4 is minus 0.6, Z inverse into Z inverse is Z power minus 2, right? So now substitute the value of e power minus 0.2, e power minus 0.4 and e power minus 0.6 and conclude this equation. That is e power minus 0.2, e power minus 0.4, e power minus 0.6. Put it in the calculator. How to write e? Shift ln e. Power, here we have minus 0.2. So let us simply put e power a, okay, and let us substitute the values of e. That is, one is minus 0.2. First is 0.818. Next is minus 0.4, 0.67, minus 0.6, 0.548. Now substitute these values in this equation, so our final answer would be equal to 0.818 minus 0.818 Z inverse minus 0.67 Z inverse divided by 1 minus, here this is 0.67 Z inverse minus 0.818 Z inverse plus 0.548 Z power minus 2. So here you can see that these two are repeating Z inverse, so we can simply add them up. 0.818 minus 0.67, that is equal to 0.148 Z inverse whole divided by 1 minus, again these two we can simplify, minus 0.67 minus 0.818, that is minus 0.1488 Z inverse plus 0.548 Z power minus 2, that is equal to h of z. So this is the final value of h of z we have got after simplification of this. After substituting the value of t here by the given frequency value of 5, 1 by 5 is 0.2, and I have done the whole calculation here. You should be very thorough in mathematics, okay? Then only you can solve these kind of problems. So this was one problem. Now let us solve one more problem and wind this session. So this is that one more problem. This is also very simple, similar to that problem, only using IIM method you should solve. The system function of an analog filter is given by this h of s is equal to s plus 0.1 divided by s plus 0.1 whole square plus 9. Obtain the system function of IIR digital filter. IIR digital filter means you should be obtaining the value of h of z, okay, in z plane by using IIM method, okay. So without further delay, let us solve this. First, we should be bringing this in terms of partial fraction method, so that we can apply the partial fraction method. For that, we should be doing some of the simplification part. That is, they have given it as s plus 0.1 divided by s plus 0.1 whole square plus 9. So now how we can write this is s plus 0.1 divided by, it is of the form a plus b the whole square, that is equal to a square plus 2ab plus b square, right? So s square plus 2ab, that is 2 into 0.1s, that is equal to 0.2s, plus b square, that is 0.1 the whole square. 0.1 the whole square is equal to 0.01 plus 9, okay, so that is equal to 9.01, right? So now like this you have substituted. Now what I am doing is h of s is equal to s plus 0.1 divided by, this here it is in the quadratic polynomial form, right? So here I am simply in the calculator I am finding the two roots and I am writing it as s minus that root, okay, so that we will be getting in the partial fraction form and we can solve it further, right? So for that what I am doing, mode setup, equation, check the degree, highest degree is 2 here, so press 3, then substitute the coefficients, that is here s square coefficient is 1, then we have 0.2, then we have 9.01. So the roots are, first root is s1, that is minus 0.1 plus 3i or 3j, s2 is minus 0.1 minus 3j. So s minus of minus 0.1 plus 3j, this is the first root I am writing, then s minus second root minus 0.1 minus 3j, okay. So in this way I have written the h of s, I have substituted so that I could solve using a partial fraction easily. Now use the partial fraction method and solve. That is, you can write it as a divided by s, minus is plus, so s plus 0.1 minus 3j plus b divided by s plus 0.1 plus 3j, okay. So in order to cancel the denominator here, you should cross multiply. So what you will be getting our equation as, in the numerator side we have s plus 0.1, so here s plus 0.1 remains, and after cross multiplying what we will be getting, a into this term, right? S plus 0.1 plus 3j plus b into this term, s plus 0.1 minus 3j. So this is the equation we got here. This you consider it as star. So from this here, we should be finding the values of a and b. For that, we should be making, to find the value of a, we should be making the value of this whole term which consists of b should be equal to 0. Okay, so what we should be substituting the value of s as the opposite polarities of this. So that if here we have plus 0.1, so we should be substituting minus 0.1. Here we have minus 3j, we should be substituting plus 3j, so that this whole term would be equal to 0. So substitute the value of s as minus 0.1 plus 3j first. So in place of s you write minus 0.1 plus 3j plus 0.1, so that these two would be getting cancelled. A into minus 0.1 plus 3j plus 0.1 plus 3j, and this term would be 0, right? So I am not writing it again. So minus 0.1 plus 0.1 again goes. We are left with 3j equal to a into 3j plus 3j is 6j. So a is equal to 3j by 6j. J gets cancelled. 3 1s are, 3 2s are, and our answer is a is equal to 1 by 2. Right? Similarly, substitute. In order to find the value of b, we should be making this equal to 0. Opposite polarities of these two, plus plus. So we should be substituting minus 0.1 minus 3j to find the value of a. So to find the value of b. So minus 0.1 minus 3j plus 0.1. Again, these two would be getting cancelled. So this a term would be getting cancelled. We would be left with only b. Minus 0.1 minus 3j plus 0.1 minus 3j. Minus plus gets cancelled. We are left with minus 3j is equal to b into minus 3 minus 3 is minus 6j. So b would be equal to minus 3j minus 6j. Minus minus goes, j goes, 3 1s are, 3 2s are. Again our value of b is also 1 by 2. So a is also 1 by 2, b is also 1 by 2. So we have found the values of a as 1 by 2 and 1 by 2. Now substitute in the equation star. Okay, and let us see what we would be getting. So h of s is equal to 1 by 2, right? We can write it as 0.5. Okay, 0.5 divided by s minus of this here, what I have written here, first right in bracket. This only I am writing it again. Okay, so because the root should be of the form 1 divided by s minus pk, right? So that's why. What we have? Minus 0.1 plus 3j plus again the value of b is 0.5, s minus of minus 0.1 minus 3j. Okay, these are the two roots here. Now in z plane it is equal to 0.5 divided by 1 minus e to the power whatever is there in the root side, that is minus 0.1 plus 3j, and here they have not given to the value of t time period. So whenever they don't give the time period, you should be writing t as it is. Okay, yeah, whenever they give it, you should be substituting the value of t and simplifying it. Okay, whenever they won't give it, you should be writing t as it is into z inverse plus again 0.5 divided by 1 minus e to the power the root minus 0.1 minus 3j t z inverse. So this would be our final answer in z plane. Okay, so like this you should be solving. This was one complex term problem. Okay, I have made it very clear and solved it. So that's all for this session, guys. We have solved two important problems. Hope these two problems were very useful to you all. So please like, share, subscribe to our channel and do support us, guys. And in the next session we are going to see with few more problems of IIM method, and we will be concluding this method. And after this IIM method we have one more method, that is BLT method, bilinear transformation method. That is still more easy, very easy. Only in place of s we should be substituting one term that I'm going to tell you in that session. So yeah, please do watch this video, those who have not watched it, and those who have skipped and watched it, do watch this complete video, because detailed explanation I've tried to provide it from my side. Yeah, so that's all for this session, guys. Like this video. We'll see you in the next session. Thank you.